Alright gang, so second part of complex numbers. Now we're going to talk about conjugates, which we've seen that word before. We're going to have a special kind of conjugate for complex numbers, which we're going to need to do division, and then we're going to talk about the roots of negative numbers. So first piece, if we want to talk about our complex conjugate of a plus bi, then our complex conjugate, meaning we just switch the sign here. Okay, that's the important piece, a minus bi. Now, when we multiply, so we see a plus bi times a minus bi, we can do it out longhand, so we'd FOIL a squared, then we'd get minus abi plus abi, and then minus b squared I squared. Now, you'll notice these middle two terms cancel out, so really we just have a squared minus b squared I squared. But remember that I squared is a negative 1, so really this would become a squared, and negative times negative plus b squared. Okay, so really when multiplying conjugates, you're going to want to remember that we can simplify the process by just remembering that it's a squared plus b squared. If you don't want to remember it, that's fine. You can always do this longhand multiplication. It's not going to take you that much longer. But multiplying conjugates, which is going to be very important for division, is always just going to get you a squared plus b squared. Looking at, if we talk about a conjugate, then multiplying them, the conjugate of this would be 2 minus 3i, which remember is going to be a squared plus b squared, or 4 plus 9 would give us 13. And that's the multiplication of those conjugates. And so then when we divide, we're going to multiply our numerator and our denominator by the conjugate of the denominator. And that's the important piece, is that we multiply by the conjugate here, and then our denominator shouldn't have any imaginary numbers left in it, because when we multiply conjugates we get a squared plus b squared. Here we're going to multiply then, an example, by the conjugate would be 2 plus 5i. And remember, we want to multiply both numerator and denominator by 2 plus 5i. Okay, now the numerator is going to be the hard part here. Remember, we have parentheses. So 2 terms times 2 terms should give us 4 terms before we simplify. Distributing my 7 times both those, I'm going to get 14 plus 35i, and then distributing my 4i plus 8i plus 20i squared. All over, remember, these two are going to give us a squared plus b squared. This is where this trick comes in nice. So we're going to end up with 2 squared plus 5 squared. And if we simplify things a little bit, remember this plus 20i squared really becomes minus 20. So 14 minus 20 is going to give us a negative 6, and then 35i plus 8i is going to give us plus 43i. All over, we're going to have 4 plus 25, or 29. Hey, now you could write it this way, that would be fine. A lot of times people will tell you that you need to write it in a plus bi form, meaning 2 separate pieces. To do that, we just say negative 6 over 29 plus 43 over 29i. Okay, that would be in a good a plus bi form. Alright, so that is how we divide using conjugates. Now, last piece is roots of negative numbers. Really, the way we're just going to, this is something called the principal square root. So because we have a negative, we pull out an I. So we just get I times the square root of b. And we've all seen that before, nothing too new for us. The trick comes when we want to evaluate an expression that has negative in both of these, and we need to remember order of operations. So really, we simplify the roots first, because roots are exponents. Remember, we could write a square root as 1/2. So we don't want to just say that this is a square root of 100, because that would be wrong. We need to evaluate each one of these roots first. So this first one, we'd pull out an I, and then we'd have the square root of 25, which would give us 5i, times the square root of negative 4 is going to give us 2i, which means we have 10i squared, or I squared is negative. That should give us a negative 10. Okay, so that's where we need to be careful. If we multiplied them first, if we did not order of operations, we'd get just 10, which is not what it should be. It should be negative 10. Okay, here a subtraction sign. So this one's a little bit trickier. This goes back to some stuff we've done before. So negative 18, I'm going to pull out that I, and then I'm also going to think of 18 as 9 times 2, because the square root of 9 is going to give us 3, and then I'll have the square root of 2. Minus, same idea, pull out that negative sign. I'm going to pull out an I. Give myself a little space there. Okay, pull out an I, and then I'm going to think of 8 as 4 and 2, because the square root of 4 is 2, and then square root of 2. And now this becomes a subtraction problem like we saw in the last lesson. So 3i squared root of 2 minus 2i squared root of 2 is going to give us just 1i square root of 2. Okay, and that would be as simplified as we could go on that one. So that is it for the last part of 2.1, complex numbers, part 2. Big thing here is to remember your conjugates. So when you're dividing by a conjugate, or when you're dividing using conjugates, multiplying conjugates is always going to get you a squared plus b squared. And then roots of negative numbers using that square root property or property of square roots. All right, talk to you next time.